All right, folks, welcome back. This is a combo lesson between 7.2.4 and 7.2.5. You'll find 7.2.4 on the front side of the notes page and 7.2.5 on the back. The title of 7.2.4 is More Properties of Quadrilaterals. And what I want to highlight here is that much of the stuff in this lesson really goes back to this org chart, and it goes through and proves what I was calling features for quadrilaterals. And I'm going to do a couple of those in this video, but again, as I've stated before, I don't stress that as much. I don't stress proof as much as maybe was done in the past with geometry classes. All right, I want to just make one more comment about proof. Earlier in the year, when I asked you what is necessary to prove something, and unanimously the class said evidence. Okay, and in geometry, evidence is very tricky to come by sometimes. It's not always obvious, and what a student thinks is evidence might be different than what a teacher thinks is evidence. Okay, so let me tell you what the format of 7.2.4 is. Basically, there are three different proofs here, and the proofs are already given to you. So I've basically given you the proofs, and I really just want to walk through them with you and help you understand them. The first one is pretty straightforward. It doesn't even involve quadrilaterals. It just involves our friend the isosceles triangle. So we're given an isosceles triangle ABC, and we're asked to prove that angle A and angle C are congruent. We all know that. We know that we've been told in the past that the base angles of an isosceles triangle are congruent, but why is that true? And I'm going to walk you through that proof now. Okay, so the first fact that we're going to add here is I'm going to draw a new segment in the picture, and I'm going to label it BD, and it has to bisect angle ABC. So that's going to look like this. Okay, I'm going to draw that segment there, and there's a way to construct that with a compass and a straight edge so that you actually bisect the angle. And that means that I'm adding this point right here, and I'm going to call it point D. So BD bisects angle ABC, and if we bisect angle ABC, that means that these two angles have to be congruent. Okay, now let's look at a couple of the other facts in this proof. BD congruent to itself, that's called the reflexive property. In the past, we've also called that shared side. So I'm going to go ahead and mark that side congruent to itself. Last but not least, I have segment AB is congruent to CB. That's given because we know that we have an isosceles triangle. Okay, so if you take a look, we have three pieces of information in the two triangles. We have side, angle, and side. Therefore, we can make the statement that the triangle on the left, triangle ABD, is congruent to the triangle on the right by side, angle, side. What we can now do is add to that. I'm going to add this in a different color. Let's go with green because green means go. I can make the conclusion that those two angles are now congruent because corresponding parts of congruent triangles are congruent. And you remember in a previous video we called that CPCTC, if I could even write. CPCTC. Sometimes you'll hear this set of symbols referenced as CPCTC. Okay, now I do want to make one thing clear. Be careful if you add these symbols to your picture, because really, if you add those symbols to your picture, you may not understand. You can't put them in the picture right away because that's what we proved. Now that we've proved it, we can say for the rest of time that if you have an isosceles triangle, the base angles are congruent. Okay, let's jump down and take a look at this second proof. This one will involve a quadrilateral. It's our good friend the rhombus. Okay, so we're given that ABCD is a rhombus, and we have to prove that angle ABD, that's this guy right here, is congruent to angle CBD. So that's what we're going to be proving in this flow chart. Let's start with the first piece of information. ABCD is a rhombus, and that's given. Now, we know the definition of a rhombus is that all four sides are congruent, so I'm going to add congruent marks on all four sides. And there we go. Now let's take a look here. We've got a shared side, and it may not be obvious that we're going to prove this with congruent triangles, but that's where we're headed. We have a shared side. DB is in both triangles, so I'm going to mark that congruent to itself, also known as the reflexive property. We call it shared side or reflexive property. I have no preference which you use. I can now say that the triangle on top, ABD, is congruent to the triangle on the bottom, CBD, by side-side congruence. Okay, so now we have two triangles are congruent. We can match up their corresponding parts, and I'll add this in green. Angle ABD is congruent to angle CBD. Okay, and right now I know what you're thinking. Why on earth would Mr. Vass go through the last 5 minutes and show us this proof? Well, the reason is as follows. Take a look at the org chart. Let's go to our friend the rhombus and take a look at this feature right here. Each diagonal bisects two angles. We just proved that the diagonal of a rhombus bisects these top two angles, and we can add the bottom two there as well. So this is a feature that we've just proved. Okay, the first angle that is bisected is this guy up here because it's split into two equal parts. The second angle that is bisected would be this angle down here. So if you really wanted to, you can add the congruent marks down here as well. Okay, let's move on to the third and final piece here of 7.2.4. And again, this one involves a quadrilateral, this time the rectangle. So we're given a rectangle, and we have to prove that AC is congruent to BD. And you'll notice that AC and BD, those are the diagonals. Oh boy, spelling, struggling today. Diagonals. And the diagonals are the line segments that connect opposite vertices in a quadrilateral. Okay, so let's take a look at the proof. ABCD is a rectangle, given. That's great. DC is congruent to CD. Now, one of the things with this proof is that we have two triangles that we're going to be proving are congruent, but they overlap with each other. So I'm going to, one of the practices I like to do is to draw them separate. I'm going to do that real quick. So we have triangle ADC, which is pretty easy to see. That's the one here that's in the same orientation. But then there's triangle BCD, which I've flipped. And the only reason I flipped that is because it's a little bit easier to see if we match up the corresponding parts in the same orientation. Okay, back to the proof. I said here a second ago that DC and CD are congruent, and that's the reflexive property. You'll see that those are actually the same segment right here. We also have that angle ADC and angle BCD are right angles. That's the definition of a rectangle. Rectangle is a quadrilateral with four congruent angles. I also have here that segment AD and segment BC are congruent. And that's because opposite sides of a parallelogram are congruent. And I know what you're thinking. We're talking about rectangles. Why on earth is he using something about a parallelogram? Well, a rectangle is a parallelogram. If you don't believe me, go ahead and check out our feature page. So we have a rectangle. It says, yeah, right here, it's a parallelogram. Now, that is something that, because it's a feature, would have to be proved with another proof. And all these proofs trickle down. So opposite sides are congruent is a feature of parallelograms I'm using in this proof about rectangles. Okay, next, I've got my final triangle congruent statement here. Triangle ADC is congruent to triangle BCD by side angle side congruence. And I can see the side angle side right here. I got one pair of congruent sides. I got a pair of congruent angles that's between the second pair of congruent sides. Now I can make the extension to say that segment AC is congruent to segment BD because corresponding triangles have congruent parts, and that would be this third segment in the two triangles, which happens to be the diagonals. So that is a feature now of rectangles. Let's take a look at it in our org chart. Diagonals are congruent in a rectangle. And that's a feature. All right, folks, I'm going to shut this video down and pick it up in part 2 for page 2.